Okay, so we're going to be testing for the halide ions here. We have potassium chloride, potassium bromide, potassium iodide. I'm going to add nitric acid and then silver nitrate. So first of all, just an equal volume of nitric acid to each of them. And then in the silver nitrate. So here we can start to see the colour changes. Now these are all quite similar colour changes, but it's very important to remember the differences between them. So here we have white, cream and yellow. So I've divided these in half now, and to this half I'm just going to add some dilute aqueous ammonia solution. And we can see that not a lot happens. So to confirm the identity of these ions, I'm just going to add some more concentrated ammonia solution and we will see what happens. So I'll add a bit more to that so we can see if we can get it to work. So hopefully what you can see happening in this one, and we can see it a little bit in this one if I just bring it a bit closer, that the white precipitate is actually gone clear at the bottom. That's because the white precipitate has redissolved in the ammonia solution. It should happen a bit more with the concentrated, but it doesn't look like it is. This one has dissolved a bit, but you can't really see it, and the precipitate here shouldn't dissolve at all. So here we have solid versions of the halide ions. I'm just going to add a couple of drops of concentrated sulfuric acid to this, working with fume grade because concentrated sulfuric acid is nasty stuff, and then we're going to test the gas that's evolved. So you can see that fizzing away. I'm just going to pop that in there so we can try and see what happens to some of the gas. And you can see the litmus paper is turning red. Let's test the next one. So with bromide, you can see this is fizzing away furiously. Just pop the litmus paper in the top there, or drop it in, and you can see it's fizzing away and has turned red. Potassium iodide, we can see that has gone a dark brown colour, and the litmus paper is turning red straight away. If you listen carefully, you might be able to hear the hiss of the gases. Okay. So here we have some potassium bromide and some filter paper that's been soaked in acidified dichromate solution. I'm going to again add just a few drops of the concentrated sulfuric acid to it, and then add in the filter paper soaked in dichromate solution, and we will see what happens to the colour. So you can see this is waving around. That is because there is quite a lot of gas coming off here. And you can see the filter paper is turning a dark orange colour. And it's being bleached and going a dark orange colour. Here we're going to go over the many tests for the different halide ions. So hopefully you should know what colours the halide ions go. So fluoride ions aren't going to have any reaction, so you're going to have new precipitate. Chloride ions are going to give you a white precipitate. Bromide ions are going to give you a cream precipitate, and iodide ions are going to give you a yellow precipitate. This is a really subtle colour change, so it's well worth remembering these. Now the reaction that I'm talking about today, we actually added nitric acid to, like hydrochloric acid previously, the nitric acid just removes any unwanted ions. That might contaminate the results. So the reaction that produces the coloured precipitate is between a potassium, and I'm going to write potassium halide, and you can replace that with any halide that you're talking about, and the silver nitrates. And then you are going to get a silver halide and potassium nitrates. The reaction for this is KHA, HA here just being a halide, plus the silver nitrates is going to be silver halides, and we'll say AgHA again, the HA just being any halide you want to replace it with, and potassium nitrate. And it is actually this bit here, the silver halide, that goes cloudy. That is going to be our precipitate, which is going to change colour depending on what the different things are. Now there are a few things that you can do after this. We are going to add ammonia now. And the result that you would expect is that a chloride is going to precipitate dissolve to colourless in dilute ammonia. The bromide when it's in concentrated ammonia, and the iodide doesn't dissolve. These are really subtle colour changes to see, so you may not be able to see in the lab, and it's going to be hard to see in some of the videos as well. When we test these with concentrated sulfuric acid, we are going to see a few things. We are going to see hydrogen chloride produced as a gas. That is what's going to turn our litmus paper red. So here's an example. We have the potassium chloride, and that is solid, and the sulfuric acid. We are going to get hydrogen chloride coming off as a gas. And then this bit here is going to be acidic, and hydrogen chloride in itself as a gas isn't acidic, which is why we needed damp litmus paper. it wouldn't have worked with dry litmus paper because the hydrogen and the chlorine ions need to dissolve in the water so they can separate and become acidic. With the potassium bromide, we did the same thing. We added in sulfuric acid. And we got a few things out. We got potassium hydrogen sulfate, we got bromine, we got sulfur dioxide, and we got water. If we look at that reaction, we have this is a really, really complicated equation to balance. If you try and have a go by yourself, that's fine. If you can't do it, I suggest you check out my video on how to balance equations using oxidation states. So what you saw with this reaction is a brown gas release. That is going to be the bromine. And then we tested it with acidified potassium dichromate. And the reaction here was looking for oxidizing agents. So the reaction that actually happened was the ionic equation. That's the equation that we're actually interested in. What the potassium ions are doing aren't necessarily of great interest to us in this reaction. So this is just the same equation as before, but just looking at the interesting ionic parts of the equation. Now we're going to be looking at the sulfur dioxide, and we're going to be looking for this reaction with acidified potassium dichromate. So we have the potassium dichromate. Now, if you've seen Erin Brockovich, this is the hexavalent chromium that they talk about in the film. It is a very toxic, very dangerous and horrible stuff. So we have the potassium dichromate, 6 sulfur dioxide, sulfuric acid, and that is going to turn into chromium 3 sulfate. If you're not sure what all of these Roman numerals, this 6 here and this 3 here mean, go look at my video on oxidation states. Potassium, potassium sulfate and water. So this is the reaction that we're actually interested in. So we are going to have the potassium dichromate here. This is another reaction that is really horrible to balance if you don't use oxidation states. And it's a very long reaction, so yes, I'm probably going to go off the side of the page. And what you're actually going to see is that this one is orange and this one here is green. Sometimes it looks like a greeny browny colour. That's because it would just be mixing with the orange, and that is going to show the presence of a really, really strong oxidizing agent. the orange dichromate ions are going to have been reduced to the green chromate ions. And then we reacted potassium iodide with sulfuric acid. The reaction for that, again, it's a really horrible one to balance unless you're using oxidation states. The hydrogen sulfate is really toxic, really horrible, and smells like botanate. So this should definitely be done in a fume hood. This here is going to produce your colour. That is going to be your purple vapour, and testing for hydrogen sulfate is going to turn the filter paper soaked in lead nitrate silver, although I will admit whenever I do it, it looks black. Thank you for watching. I hope you found this helpful. Subscribe so you don't miss any more of my videos. Donate so I can buy stuff to make more videos. Share this with your friends so that they can help improve their grade as well. Any comments, questions, requests or corrections down in the comments below, please.